It passes fast, it passes in less than 3 minutes. I think that's it. I think, honestly, I don't... yeah, I've resolved that problem. I don't think I would be able to resolve it. I guess my imagination was a bit constrained there. But yeah, in essence, that's it. You know, it's like the kind of qualitative passes the tests aspect is now finished. I pass all the tests in about 3 minutes. But quantitatively, some of the tests are going to fail occasionally, and I may or may not decide that that's worth investigating and debugging. So yeah, that's what I'm saying. So now that that's done, what follows is just a stress test with the finalized code, the code that I have up now. Because I don't realistically want to make any more changes to it. I don't think. Allows quick exits for testing. So just leave it alone, I guess, and run the stress tests and hope that they work out. So what I mean by stress test is just run these tests, 100, 200 times. And yeah, just log the outputs in the situations that one of the tests fails. Yeah. I guess I can do that. Is that it? Is that all that I want to do? Yeah, I suppose so. The other idea I had was that I wanted to look into this test, which is slightly unreliable for my liking. But because I've made two or three changes to the code now, I would rather rerun those tests. I'd rather rerun all of these tests to see where I am. So this is just like my first batch of tests. These tests are all it's run the same test 200 times. So I can do that. I don't have to strictly run them all one after the other 200 times. I can do a completely randomized testing order if I want to. That's totally legit. I can do that. But I can also just run the tests in order as a full Go test suite. So, I can do Go test 100 times, and I can do randomized sequential, i.e., the processes actually exits between each test. Individual tests each 100 times. Yeah. So I think that's a good way to end. I think that's a good way to run the stress test. And I would say, because I'm not an obscene perfectionist, if it passes over 90% of the time, I think I'm going to leave it and move on, because I'm doing these projects after all to learn. They are just coursework projects. I don't need it to be ridiculously reliable. This is not in production code. Unlike all the other stuff I've done so far, where I made it extremely reliable, it doesn't need to be above 90%. But this, for example, I'm looking at the 30 fails here. It's 15 fails out of 100. I'm already thinking that's quite a lot, and I'd like to at least read through the debug logs to see if there's anything I can fix there. So I'm not sure. Maybe I should do that now. Shall we do a quick diagnosis to see? I'll do that very quickly. I'll do a diagnosis to see if I can identify why these tests have been failing, because I have them all saved. I have the output for the failing tests saved. And then after I've done that, I'll go ahead and implement these tests and then jump off the stream, run them, and do a kind of closure slash, oh, I've identified a bug, let me fix it and rerun the tests every, they're going to be very short streams, but they're going to be quite intermittent because I'll just be doing stress test, and it'll be done soon enough, and then I'll do a final epilogue closure on Raft, because Raft is done. It's all finished. I can't believe it. It's not fully understood, but it's pretty difficult to fully understand something like that, and I'm pretty happy I understand it very well, so I'm happy. All you need is happiness. Alright, so let's do that. Let's have a look at some of the results to see if we can identify why test 2A2 has been failing 15% of the time. Let's do it. So, all the other tests have been failing very rarely. One other thing I actually want to do before I get into that is just have a look at my timeout variables and see if I can optimize those slightly. So these are the variables that kind of control the timings of how Raft, of the Raft program. And I mean, I don't know if it's worth me messing about with this stuff too much. In principle, it'll make the program slightly faster, but it's already sub 3 minutes. Well, it was sub 3 minutes this time. This time that I ran it. I may as well run the test again, actually, just for the lols. For the hell of it, just to get another example of everything passing, hopefully. Yeah, everything should be passing now, because all of the tests have a high probability of passing. But yeah, I'm thinking, I could cut down the election timeout slightly. Maybe that would make it faster. Maybe I should leave it alone. These numbers are all pretty reasonable in my opinion. Maybe it's not necessary to cut them too much. Sorry about the breathing. It's still slightly a bit of a cold, a bit bunged up. But I don't know. I could cut the election timeout down to like 400 seconds, and it still has the randomization of 300. So I think it should be pretty reasonable. Unless we randomize it to 200. I'll tell you what I will do, actually. Do you know what? What I'm gonna do is run tests, do my thing where I run the test 100 times, but I'll do it with a few different settings for the election timeouts, and then we'll be able to compare them and see how things are going in terms of timings and all that. Yeah, I think, why not do that? Let's do that. So the settings I'll do are the standard settings I've been using so far, but I'll also try 400 and 200, I think. Maybe just 4, or like 300 and 200. Or actually 300 and 150. Maybe I should cut the heartbeat timeout out completely. No, don't do that. Don't cut the heartbeat timeout out completely. That would be a mistake, I think. It's already tiny. It just, having it non-zero allows a context switch to happen, and I think that's pretty important, to be honest. So yeah, say I cut it down to like 300 and 150 and just, I don't know, see if it still works. Do some stress tests. I'll do those two settings. And perhaps choose a few others, I don't know. But yeah. And then you'll be able to see my progress when I stream the results. The results of them endeavors. Camera, mic, live. So yeah, I mean, as you can see here, this is just passed again, no problems. Those figure 8 tests take over a minute just by themselves. So yeah, I'm gonna be running the full Go test 100 times to see if it passes, and also go ahead and run individual tests. Let me do that, because I said I was gonna. What order did I say I would? Oh, it's over 3 minutes. Ooh. What order did I say I would do things in? I said I would first try to investigate briefly why this test that used to be. I don't know if it still is, because I've made a few changes to the code in the meantime. But we had one test that continually failed. as in it failed 15% of the time, and you can see here 30 failures because we tested 200 times. And I just wanted to see if I could identify, what happened to cause these failures in the test. Let me move my butt. I'll slide it up actually because I was just trying to get comfortable, and no, this isn't going to work. I'm going to have to fully reposition. Just give me a sec. Oh God, it's got to be extra careful because if I'm not, whoa, Ethernet cable is just going to completely, it's going to fall out, and I can't have that happen again because that cuts the stream out, and it's just annoying to get it sorted out when it happens. Whoa. Sorry, okay, I'll just slide the mic over. Is the stream still up? No guarantees, but yes it is. Okay, good. Okay, just tilt the camera back up. It's going to require a refocus, but that's fine. It's awful. I actually focus using like blackheads, like the texture of my skin, which is just like, those blackheads should not be there. What's wrong with you? Sort your face out. Sort your life out. You're done though. God, I've been so deoxygenated lately. I really need to just go outside more. Okay, so let's take an example. Take a look at this test, for example, which actually failed 3 times in the first 10 attempts. So it's like this test does fail quite often. So it would be good. It would be good to figure out what happens. It reaches a steady state where server 2 is sending append entries out, and they're all timing out, and no one's receiving anything. And it's just saying how it failed to find the leader. Alright, let's have a look at the actual test. This is not enough information. So the test itself, in test.go, all the way down here. The test name is 2A2. Oh shit, I can't even run my individual tests anymore because I reset their names. Oh dear. Okay, do you know what? That is such a convenience that I'm even considering putting the numbers back in, because renaming the test should not do anything. But I don't know. Okay, do you know what? I'm not even going to do that. Instead, what I'm going to do is just run all the tests in order 200 times. Fuck the randomized thing. I'm just going to allow it because the effort of putting the names back in, and then I've edited the tester file, and I want it to be identical, just because I don't know, paranoia or whatever. So yeah, just fuck it. It's not worth the effort. What happens here? We begin the test. A leader gets selected. It gets disconnected. We check leader again. A new one should be elected. If the old leader rejoins, it shouldn't make a difference. So it just brings the leader back in, checks if this is still leader. If there's no quorum, no leader should be elected, and then it runs. Disconnect of 2, sleeps, check no leader. And then it reconnects 1 and checks 1 leader again. Rejoin of last node shouldn't prevent the leader from existing. I wonder which one of these parts actually causes the fail. I'll tell you what, I'm going to do a quick commit on Git. Reason being that I want... What do you mean DS original? DS original is from a different closed repository. Thanks. Would be good. That was from a different folder. I don't know why it was coming out. Reset testing files. I'll tag it with 2 as well because Raft is project 2. Reset testing files, all good. And I'm just gonna like, now that that's committed, I can edit the tester file again. All I want to do is, oh wait, but that would require me to re-debug everything. Okay, let's not. Okay, let's just leave it alone. So as in, I just remembered if I edit this, then the output is not mysteriously going to appear here. It's going to have to, you know, I'm going to have to rerun these tests again. I mean, what happens here is like, I don't know, like server 2 just. Do you know what happens? Servers 1 and 0 are still working at this point. They're still like connected. They're all in the cluster and shit. But then what happens is eventually just, I don't know, 0 becomes a candidate. 1 becomes a candidate. Everyone is more or less disconnected from themselves. 1 requests votes from everyone. So it's just all the servers being disconnected. I wonder if the testing is maybe not reliable enough, if that's what's causing this to happen. Because you can see here, if you ignore the question marks, which just denotes timed out RPCs, you can see only server 2 is doing anything, so it kind of looks like servers 0 and 1 fully crashed, which is a bit strange. I don't know how that happens, and it could have something to do with how I was exiting, you know, with my log, but I mean, the kill thing should only be called after the testing finishes. But possibly, I don't know. I'm thinking, you know, the kill functions, they're supposed to be only called after a test finishes to close things, but it might be that like some of the tests were failing because the kills from the previous tests were killing the current things, and so we got some like intermittent behavior. Because yeah, you can see here, only server 2 is alive, which is ridiculous, isn't it? I don't know why that would be happening. 15% of the time. Yeah, very much to me it just looks like those other servers just fully crashed for some reason, and it's not clear why they crashed. What was the last thing that they did? So what I'm looking for is you know, here for example 0 is sending request votes, and I think 1 does the same thing. But like after a certain point, it's just 2 that is appending entries and sending heartbeats. So many heartbeats. You can see a complete. If you squint and scroll, you can just see a complete regularity in what's happening here. Some really old RPCs time out, but that's not so important. Okay, well, it is actually a minor edit I want to make, is that I think the RPC's timing out messages are causing more confusion than they're worth, and so I'm just going to get rid of them. RPC timeout messages, they're in the sender. You know, it says if not okay, this message. I'm going to comment them out because they're just confusing me, to be honest, reading them. I think, yeah, the return should still be there, but yeah, fair enough. And done channel false, which is the auto vote for false in the case of a timed out RPC. So yeah, I've gotten rid of those, so next time I debug, they will not be there. Damn it, my file unloaded. Yeah, but what else is happening in the file though? It's like the control S there to save. What it does is you know, if I open a file like this, if I control S, it goes from italic to not italic, and all that means is that the file won't be closed when I navigate away from it because it's already saved. You know, the dot means it's unsaved in Visual Studio Code, but like if there's no dot, saving can still make something not get closed when you navigate away from it. It's quite a convenient, neat feature, I would say. Very intuitive. Yeah, I mean, without the timeouts, if I scroll up through this, it's just 2 that's sending heartbeats constantly. Do you think the heartbeat timeout is too low? I think it might be. Maybe the heartbeat timeout being low is just, I don't know, causing 0 and 1 to not work. But then why does it usually work? I don't know. It's a bit strange, isn't it, looking at this? It only fails 15% of the time in this manner. I think it could just be that the heartbeat timeout is too low, to be honest. I think that could be it. So what I want to do to identify that, as part of my testing, so I'm going to, just cut the stream. And as part of my testing, I'm going to, well, for starters, put the number back into the test file temporarily so that I can run the same test. Run this test that was failing. And I'm going to run it with 2 different heartbeat settings. So the original 50 milliseconds and 100 milliseconds as well, 1 decisecond. Those 2 settings, and I'm going to see if that helps, because it could just be that the heartbeat is too fast, and so the other servers are not getting run successfully by the computer if it's in a single thread. But in the real world, these will be getting run on separate computers, so it shouldn't matter. So I think maybe, considering this is a multi-core machine, and the tester I think should take advantage of that, I think possibly it's not actually that. I think it might actually just be 0 and 1 crashed for some reason. Can we identify why this has happened? So 1 sends a request to vote. It sends out these messages, and then just like, it doesn't terminate anywhere, there's no log dump. Do you think it just locks permanently? I should also run the race condition detector. Here. You should check your code with go test race. Shall we just do that quickly? I don't think I've actually done that so far. Is this working? It looks like a crash dump to me, but I think it is working. Or is it just like fully report? Oh, it's actually just reporting bare race conditions, isn't it? Ah, interesting. Warning data race. Huh. That's very interesting. This will give us a bit of extra evidence. I'm going to log this to a file which is going to be called like race reports or something. So it'll give us some other information about what could be going on. Wow, this is an infinite dump. The length of some of these dumps is ridiculous. Okay, yeah, it's a good point. You should check your code with this to fix any races it reports. That's pretty reasonable. Because that's the kind of thing that, could be causing this kind of thing to fail. God knows. Concurrency is a bit of a well. But there's no other reason I can think of that this should be failing. It's just like server 1 sends out request vote, and then it just like is never heard from again. So it might just be that it exited for some really random reason. So it just has an intermittent crash bug. But it's not a crash bug, it's a safe exit bug. So it's just logic that's closing the programs down incorrectly. So that could be causing the lower reliability on that particular test. Yeah, I don't know. I would say, just I'll do like 1 or 2 of these race reports, try to read them, figure out what's going on. It says a hell of a lot of just warning data race. What I should definitely do though, because bear in mind my print debugging causes a lot of race conditions, just generally speaking, because I've not been using the strict convention for when to lock and unlock. I've just been, introspecting without using locks, but only in my print debugging statements. So there is that. Okay. That's given me a bunch of stuff to think about, to be honest. So I'm just going to decide on a kind of order of operations, I guess, and see if I can just kind of settle all that stuff down. You know, just as a my kind of finishing procedure. The code is, you know, it's all more or less done, but as you can see, there are problems. Oh, look at this, fail. So it ran the full set of tests, but with the race condition detector, which only added about 10 seconds, in fairness, and has logged, you know, a ton of races in just random locations. Well, you can see kill is causing a lot of races, which is fair enough. Some of the races seem to just be getting caused by, I don't know, other stuff. Are all of these race conditions just being caused by the way I've implemented kill? I think they might be. I think kill is, yeah, okay. Let me just put the kill within the lock. That's probably going to help quite a bit, actually. It might even get rid of all of these race conditions. So here I was just saying, like, the way my kill function kills things, it just it just overwrites a phase quite brazenly. So I'm just going to do a lock unlock phase overwrite. So yeah, there is going to be an unlock at the end. I've decided that's fine. Get rid of this. This is no longer necessary. I'm pretty sure I'm never going to use this again because this solution seems to work better. But now that the exit is being done within lock and unlock, I think race condition shouldn't be a problem anymore. I guess there is that deliberate race condition that I left in the code. I need to watch out for that as well. So many things to watch out for. Go test, race. Yeah, let's just quickly run it and see what happens. Well, you can see races are still coming up. I like how the go routines are numbered. You know, race detected during execution of test, then it's a few tests passed. Then there was a race and it's going to fail again. And okay, let me stop this, please. Cool. I'm gonna do the same thing, except I'm gonna just dump it in a file. Okay, so do I try to fix this stuff now? As in just run the race condition detector once in a file and just go through it and see what the races are? Yeah, it's just that thing of having a deliberate race condition that's a bit strange, I guess. I don't know if I should... Do I want to do that now? That's all that I'm thinking about at the moment. Or do I just leave it for another day? Do I want to look through like a pile of race conditions? Well, I may as well, I may as well run the thing. So it's going to be logged into a file called race. And that'll take about 3 minutes to run. Because it's testing everything. I have my stress test as well, my just iterated testing. I'm going to do that at some point. Go test with the race condition. That should not be done with the print debugging on, because the print debugging will cause a ton of race conditions, I think. Well, if MIT's advice is anything to go by, because they were saying, like, even if you read a variable, that could cause a race condition. Even if it's just the reads being done somewhere. Well, yeah, it'll get detected as a race condition, obviously, because the code has, the tester has no way of knowing whether the read is done by something that is going to use that to edit the program, because it's just a print debug statement. We know it's not, but the tester doesn't, and so it'll flag it as a raised condition probably. Yeah, there is that, I guess. Okay, well, whatever. Let me just ditch append entries and request vote now that I've commented out those useless statements. So yeah, that's why I don't want to run the raised condition detector while the print debugging is on. I want to do one or the other, but I can just turn on the print debugging later.